All right, guys, let's talk about vodcast 8.3. We're going to talk about limiting reactants in this section. And to show you what limiting reactants are, rather than do like a definition, I'm going to show you, just sort of show you a little bit, I guess, about what they are. This is an important part of stoichiometry. And some would say that it's the harder part. But if you can do the regular stoichiometry, this shouldn't be too bad. There's just sort of a little bit in the middle where you have to do a little analysis thinking part. Okay, so to start off, let's look at this and say, okay, we've got a bicycle here. And we're going to break this bicycle up into parts, much like we might take a chemical compound and break it up into the atoms that make it up. And so I've got a seat, and I've got a handle, and I've got a frame, and then I also have two wheels that make up that bike, okay? So two of those. So if we're going to write that out and say, what do we have here? We would say that I've got one seat, okay, one handle. Guess it would help if I spelled everything right. One frame, okay, and two wheels. And those are the components that would go into our making up our bicycle. Now, if we're going to write that like in a chemical formula sort of way, we would write it like this. I would say that I have one seat plus one handle plus two wheels plus one frame will build me one bicycle. Okay? We could even set that up and make it like even more like chemical formulas. Like we could make seat S and that H, and then wheels are W, and a frame is F, and then we would say that a bicycle is made up of SH W2, because it takes two wheels, and a frame. Okay? Now, if we said all that, here's the way limiting reactant works. Limiting reactant is worried about what things you're going to run out of. Okay? So, and I'll pop that definition up on the screen, but limiting reactant basically means the chemical that you run out of. Okay? That chemical determines how much stuff you can make, okay? And we're going to see this here. So let's assume that like I'm in my bike shop and I'm trying to make a bicycle, and this is what I've got given to me. I have 100 seats, I've got 40 handles, 50 wheels, and 75 frames. And so to determine how many bicycles I can make, and so let's say that that's my question, okay? Let's write that down. How many bikes can you make? Okay, because that's kind of an important question. You know, you're trying to do inventory and plan out your budget and your bills and stuff, and you're thinking, okay, I'm going to sell so many bikes and make so much money. I need to know how many bikes I can actually construct out of these materials. Okay, so what I need to find out is what is the limiting reactant, or in this case, since it's not really chemicals, what is the limiting ingredient, or what is the limiting part, we could say in this case. Now, the temptation is always just to sort of jump in and say, okay, well, whatever I have the least of, that must be the limiting reactant, right? Or that must be the limiting part. I mean, if I've only got 40 handles, and that's the least amount of anything, I got 100 seats, 40 handles, 50 wheels, 75 frames, then I must be going to run out of handles before anything else, right? Not quite. And the reason why that's a not quite is because if I look at how much I need to make each thing, I actually need two wheels to make each bicycle. Okay? So let me write that out real quick. I need two wheels for one bicycle. And I know what you're thinking in your head. You're like, darn that Arnold, he is always putting everything into equalities. Okay? And that's kind of the way this works. So if I need two wheels to make one bicycle, and I set up a conversion factor here, that would mean that I'd put two wheels on the bottom and one bicycle on the top. Okay? And when I did that, I would get 25 bicycles, right? And just to make sure that I'm not totally crazy here, which, I mean, is plausible, let's do that same sort of deal for the handles and see how that worked out. If we look at our equation, one handle makes one bike, right? Or I need one handle to make every bike, I guess would be more appropriate. So one handle, one bike. I'm going to shorten this because I'm lazy. And so if I did a conversion factor here, and you can already see where this is going, but one handle, one bike, okay, and that I can make 40 bikes that way. But I can only make 25 given the wheels that I have. Now, are any of the others limiting? Well, they're 1-to-1 too. It's a 1-to-1 ratio between seats and bicycles, so I can make 100 bicycles with that many seats. I can make 75 bicycles with that many seats. So what you're looking for is the lowest amount, okay, the thing that you're going to run out of. And this is what I'm going to run out of. If I started making as many bicycles as I can make with these parts, I'm going to run out of wheels before I run out of anything else. And so basically, I'm going to get to the point where I can only make 25 bicycles because I'm out of wheels, okay? And that would make wheels the limiting, okay, reactant, or part, we would probably say in this case, but if we're talking about chemicals, we would say that was a limiting reactant. Okay, so definitions hopefully popped up, you got those, but let's talk about how this actually applies to chemistry then. So we got a chemical equation, okay, calcium hydroxide plus hydrochloric acid gives me calcium chloride and water. And then I've got a problem, and it says if you've spilled 6.3 moles of hydrochloric acid and put 2.8 moles of calcium hydroxide on it, which substance is the limiting reactant? In other words, okay, when you see limiting reactant, you always think, which thing am I going to run out of first? Now, here's the key. It doesn't always tell you that it's a limiting reactant problem. So here's your clue that it's limiting reactant. I have two numbers given to me, okay, and both of those numbers are reactants, okay? If I have two amounts of reactants given to me, probably a limiting reactant problem, okay? So how do we set this up? This doesn't work out like a normal given and unknown sort of problem, at least not for the limiting reactant part. So the first thing you always want to do is write down your two things. I've got 6.3 moles of hydrochloric acid. I've got 2.8 moles of calcium hydroxide. Now, here's where it starts to get real important. Your first step is always, if they're not in moles, turn them into moles. And we'll do that in the next problem. This one is in moles. Once you get both of your reactants in moles, I want you to put a box around them. Okay, and this is just sort of the way I like to teach this. So if you watch another video on this, it might not turn out this way, and that's okay. But I want you to put a box around those two things. And I immediately want you to write in that box in big letters, okay, have. This is how much stuff I have at the beginning. Because what I'm going to do is I'm going to transform one of these into the other, and that's going to be how much I need, okay? And I'm going to compare it to how much I have. So it's real important that you keep have clear. Okay, so next step. I am going to take one of these two. It does not matter which one. I always do the first one I write down, not because I have to, more for the sake of I like to have consistency and do the same thing every time. And I'm going to use the mole ratio between these two things to determine which one is limiting. I'm going to turn it into the other one. Okay, how does that work? Well, what is the mole ratio? I've got 1 mole of calcium hydroxide, okay, equals 2 moles of hydrochloric acid, right? And so I want to turn hydrochloric acid into calcium hydroxide. So I'm going to put 2 moles of HCl on the bottom, okay? That'll cancel out moles of HCl. And on the top is going to go 1 mole of calcium hydroxide. All right? So we punch that into the calculator. I cancel out what cancels. And I punch it in the calculator, and what I get is 3.15 moles of calcium hydroxide. And here again, really important that you label everything, okay? Now, as soon as you get to that part, once you've done this mole ratio, because this is a mole ratio right here, what you immediately need to do is put a box around that part, and right next to it, I want you to write in big letters, need. Okay? Once you get that, I'm going to compare these two things. I'm going to compare, it has to be the same chemical, so calcium hydroxide now. I'm going to compare their amounts, and here's the way it works. I need more than I have, okay? Just like if I wanted to make, a bunch of bicycles, like 40 bicycles, I would have found out in that last problem that I was running out of wheels, okay? I need more wheels than I have. And so what this is in this case is I need more calcium hydroxide than I have. If need is greater than have, then that thing is the limiting reactant. So what that means in this case is that CaOH2 is LR, and LR is the limiting reactant. Okay? If your need is smaller than your have, okay, if need is less than have, then that thing is the excess, and so the other one has to be the limiting reactant. Now, it gets a little harder if you've got more than two. If you had like four, like we did in the bike example, you would have to work through all of them sort of to figure out which one's limiting. But if you've only got two, and all of our problems are just going to have two, you find that one is the excess that makes the other one automatically the limiting reactant. Okay, so this is our answer for this problem. All right, so let's work a more complicated one where there's a couple of more steps involved in doing that particular problem. All right, so I've got 8.55. Whoops. Let's try that again. I have 0.855 grams of chlorine. Okay, this stuff. And I have 3.205 grams of KBr. Okay? Clean that up a little bit there, guys. Sorry about that. Now, remember I said the last problem that the first thing that you have to do if they're not in moles is turn them both into moles. Okay? Because you can't really compare them if you're talking about grams of each thing. You got to turn them into moles first. And you can't do a mole ratio until you're in moles. So the molar mass of Cl2 is 71 grams of chlorine in 1 mole. Okay? The molar mass of KBr, I think I wrote this down somewhere, yeah, is 119. Now, you don't know those off the top of your head. You're going to have to calculate them, right? 1 potassium is 39.1. 1 bromine is 79.9. Add them together, I get 119. Okay. Again, you can go back and look at video 3.3 for that if you're a little foggy on molar mass still, which hopefully at this point you're getting a lot clearer on it. Okay, and so I do both those calculations, and that gives me, let's see, I get 0.0120 moles of Cl2, and I get 0.0269 moles of KBr. Okay, and so remember what I said was when you get to the moles of each, I'm going to put a box around it. And I'm going to label this as have. Okay? Got to do that. Make your life a lot easier. Now, I'm going to take the top one, and I'm going to convert Cl2 into KBr. Okay? Always the next step, we're going to use the mole ratio. Now, my mole ratio here is 2 moles of KBr equals 1 mole of Cl2. Okay, where am I getting that from? 2, 1. Okay, so 1 mole of Cl2, 2 moles of KBr. You punch that in the calculator. Actually, you don't even need, you could probably work this one out in your head. But 0.0240 moles of KBr now. Okay, why is it KBr? Cl2 canceled out there, and let me clear this up. I know that's some really terrible writing. I wish I could explain what happened there. 0.240 moles of KBr. Okay, and remember that what we said there is I'm going to put another box around this, and I'm going to label that as my need. Okay? And so I'm going to compare then these two things. Sorry about the text there, guys. I'm going to compare moles of KBr to moles of KBr. If you're not comparing those two things together, you're picking the wrong things, okay? Now, in this case, my need is less than, okay, need is less than have. Now, if my need is less than have, that means that KBr is the excess, okay? Sometimes we abbreviate that as the excess, all right? Now, if that's the excess, then that means that Cl2 then is my limiting reactant. And so I'm going to sort of write that by itself. Cl2 is Lr. Okay? So that answers question number 1, which is the limiting reactant. You should have noticed that there is a second question there as well, And that second question says, how many moles, how many moles of Br2 are formed? Okay, so now it gets a little trickier. So now this is a typical given and unknown. Okay, that's given and unknown type of problem. So what I'm looking for is grams of Br2, and what I have is how many moles of Cl2. Now here's the good news. I can save myself some calculation. I don't have to start back with the grams of Cl2. You're given in a limiting reactant problem, once you get to the stoichiometry part, once you figure out which is limiting, you always take the limiting reactant, and that is your given. Okay, so 0.0120 moles of Cl2. So I need to turn moles of Cl2 into grams of Br2. Always need a mole ratio, and that is 1 mole of Br2 equals 1 mole of Cl2. Okay? And then I need a molar mass. So I figure out that my molar mass of bromine is 159.8 grams of bromine equals 1 mole of bromine. Okay? So I got all that. And now it's a matter of, let's do the conversion factor thing here, okay? So, 2 conversion factors. I have a given of 0.0120 moles of chlorine. Don't forget to label it. Even if you got to cram it in there like I just did, you should leave yourself a little bit more space than I did. What works is if you draw your given and then do your railroad tracks, but I occasionally forget to do that. Okay. So got that. That's going to cancel out moles of Cl2. That's going to give me moles of Br2. I want to get rid of moles of bromine. And so that's where the molar mass comes into play. 59.8. Man, I am sorry about that, guys. Let's just rewrite that number now that I've thoroughly confused everyone. Okay. 159.8. All right. Hey, Mr. Arnold can write occasionally. Okay. So we got all that stuff. We're going to cancel what cancels. Moles of Cl2, moles of Br2. Going to be left with grams of Br2. That's good. I want grams of Br2. And when we punch that in the calculator, we're going to get, after rounding to sig figs, 1.92 grams of Br2. Now, that is a lot of stuff. It's pretty complicated. I mean, like, it looks complicated because there's a whole bunch of math on the paper. But there's basically 2 steps there for you, okay? Determine the limiting reactant, okay? What do I need to do that, okay? To determine the limiting reactant, what you need to do, okay, is convert everything to moles. That's your have. Convert one of them into moles of the other, okay? That uses a mole ratio. And then compare your need to your have. If your need is less than your have, that thing is the excess. If your need had been more than your have, that would have been the limiting. Okay? If you determine that one thing is the excess, it means the other one is the limiting reactant. Okay? And that's right there. Okay? And then your limiting reactant then becomes your given to solve for your product. Okay? So I then take my given 0.0120 moles of Cl2, and I could have started with grams. I just would have had an extra step in the stoichiometry. Okay? Do that, and then it's a regular stoichiometry problem like the other ones we've been working, where I have to do a mole ratio. Okay, so here's a mole ratio, and then I have to do a molar mass. I plug those in, and I get my answer out. Okay? A lot of math there, but really the steps are what's important. If you know the steps, then you're going to be okay on these. All right?